I would like to go ahead and would introduce you to our next eminent speaker, Mr. Kalpak Dabir. Mr. Kalpak Dabir is an entrepreneur in the field of embedded system. He has spent more than 25 years in this area and has developed many embedded hardware, software products. During his stint with various companies in the last 2 decades, he has developed a range of innovative products in the field of industrial automation, medical electronics, laboratory instrumentation, and automotive engineering. These products range from data logger, X-ray machines, touchscreens, surgical instruments, traffic light system, hybrid vehicle battery controller. He is also an active trainer in embedded system and has conducted corporate training for fresh graduates for IT companies. I'm sure it will be delighting for us to listen to Mr. Kalpak Dabir. I would like to have our MD, Mr. Johnsy, felicitate Mr. Kalpak Dabir by giving him a bouquet. Kalpak, please.
Professor Doshi has covered the field quite well, so I will jump directly into the subject matter. One of the points I would like to begin with a few practical examples. I'm sure all of you have seen a set-top box, particularly have you seen of Tata Sky? Do you realize a couple of bugs in it? Okay, you switch on the set-top box. The first thing that happens is, isn't that annoying? I'm sure you've done enough programming to realize that there's nothing but simple laziness on somebody's part to initialize that variable correctly. Is that some technology behind it? Some high funda engineering? No, there isn't. Simply laziness. Another bug you'll find is you click the mute button, it mutes. But now you try to reduce the volume. What happens? The mute goes off and again it goes to full blast. Again, is that really some advanced technology to realize this? No. It's common sense. Why am I bringing this up is because recently in the newspaper there's an article that 75% or so, I don't remember the exact figure, of the engineers are unemployable or in effect useless. Wow. Why do you say that? Is it really that bad? No. I wouldn't say it's totally the engineer's fault or the syllabus's fault or whatever. Here's another example. I'm sure most of you have seen Die Hard 4. Okay, now in Die Hard 4, how does the villain stop the hero from getting away quickly? I think it's in the first 1 hour. Make all the traffic signals green so that there is chaos at the junction and there's a traffic jam. Again, common sense. Do you really think such a system will exist where you can do this? No, I've designed a traffic control system and there's a few things you take care of that you prevent any bad programming, bug, fault from causing such a chaos. Again, that's common sense. How much of engineering is really there? Common sense in a way that you realize that a traffic control, now okay, forget the set-top box, it's a pretty simple application. Take a traffic control. Things go wrong, you can end up killing somebody. You can have an accident in the junction. If your pedestrian signal sequence is wrong, you can end up killing a pedestrian. So this is a critical application. How do you make it as safe as possible? The correct way is you do it using 2 processors or 2 parts of hardware. One is the main control that is running the regular traffic plan. So east to west should be so many minutes, north to south should be so many minutes, so much is the timing for the pedestrian crossing. There is an auxiliary processor which is much simpler. You can even say a real dumb piece of hardware that is doing only one thing. Give it a set of not allowed states. Give it a set of not allowed states, and that is what it does in monitoring. So it is sitting in parallel to the main controller For whatever reason the main controller misbehaves. It can be a glitch, a nearby writing hit, a power supply glitch. It can be a programming mistake. The moment the main controller misbehaves, it will simply shut the square down. That is, it will go to all orange flashing, the middle light flashing. So that way everybody knows, slow down, proceed with caution. I know that doesn't apply in Pune. The moment it is orange flashing, we all will rush in. So normally you will see that people follow that discipline. If it is orange flashing, proceed with caution. So that again you will realize is basic common sense. No villain can really convert a well-designed traffic square into this kind of chaos. The timing there is also specified that within say 400 milliseconds, if the main controller misbehaves, within 400 milliseconds, the auxiliary control must take over and shut it down into a safe mode. So this is not a fail-proof design. In fact, you can't design normally something that is fail-proof. What you have to aim for is fail-safe. You realize from this basically what happens is that there is really no more what you get the feeling that, oh, there is some practical aspect or hidden part of the theory still not told to you. Or what I say is Ohm's law version 2. There isn't. There isn't. I'll highlight this a bit later, what I mean by that. Okay, so let's move on to what really happens in the industry. This is an idealistic development stage, doesn't really happen, but this is how people look at it. This is also called the waterfall model. So customer comes to you with a set of specifications, converted to requirements, then architecture, design. Design is an abstraction level. Architecture is when you go back to a customer, see this is how we are solving the problem. Then comes the hard part, the implementation, testing, and the delivery. Why am I bringing this up is because probably when you join, you will begin with either being the coding people or the testing people. You probably will not be working at the first three levels: requirements, architecture, and design. So this is what is ideally so that everything works like a waterfall. Once water comes down, it can't go up. Same way you work, you finish the design, you finish the architecture, that's it, you move on to the design phase, you move on to the implementation stage, then the testing stage, and of course, you have intermediate payment plans. So the customer pays you at every stage a little bit of money. And final is the delivery when the balance, you sign off, okay, I have given whatever you wanted, this is it. Unfortunately, this really does not work. I'll illustrate that, I'll mention a few cases about that. What happens is that, and this is not a negative mark on the marketing people, I'm not saying they're stupid or something or they're non-technical people. What happens is that the customer cannot normally come up with a set of perfect requirements. They have their own pressures that, oh, we need everything. Why? Because there's a competitor also planning to do that. You're looking at a very competitive market. So you cannot say, hey, this is all I can give. Fine. You only give that, you lose on price. You have to give all these things. And of course, some of it is pure bells and whistles, not really required. For example, you may wonder, at a mobile, yeah, make a call, send SMSs, have a phone diary. What else do you really need? My God, that's a whole few years subject. What all does it really need addition? You can keep adding things. Why? Because processors are cheap. You can keep putting in more processing power. You can make it more useful. You can add a music player, movie player, and I don't know. By the end of the day, another application will have come up. So, a lot of times it's requirements plus wish list. And customer has to do that because they themselves cannot predict, nor can you, that okay, these are the 10 things you require, so therefore you will need a 400 megahertz processor with 32 MB RAM or memory and so many I/O pins and so much, such is the resolution of the graphics display. You can't predict that so well. So it begins with a wish list. You try to work out of that, you come to a realization that okay, so these are things you want, wonderful. The good way is you go back with the analysis that see, tell us the core topics, what do you really need, the core features, we focus on that first. We bring about a hardware and a firmware that supports that. Then we tackle the bells and whistles. That is a stage that takes time. So there's a kind of a feedback loop, and as you have studied that one of the best control systems are the ones with feedback. So you need a kind of feedback that, hey, okay, you want all this, but well, maybe you lose on a few things. They may not be possible. Typically, if you look at technology, really anything is possible. What it raises is the raw material cost. Oh, you want 3D in a mobile? Not a problem. I would love to do it. Well, the mobile will cost $5,000. And then the customer will say, oops, my God. Is that so? We thought technology means anything is very cheap. So it doesn't happen that way. Another gap is our own knowledge of that field. Typically, when you're in the embedded field, if there is such a field, I don't quite say there's specifically a field, but to put it another way, it's a horizontal. Speaking in industry jargon, it's a horizontal. That means it is at the bottom layer of many industrial verticals. You take automotive, entertainment, as Professor Joshi has covered. It is the bottom of many fields. So you're dealing with people who have worked in that field, that is your customer I'm referring to, who have worked in that field for years together. And they probably know nothing about what we do or how we do it. To them, electronics is really that black box. It's a magic box. Give it certain inputs, it's supposed to do what you expect. So in such a situation, you run into a lot of issues even with specs. For example, take the simple word portable or take the word mobile. If you're Steve Jobs, of course, some things are forgiven. You can say to your customer, you're holding the mobile the wrong way. But for us lesser people, that freedom doesn't exist. So you realize that portable means a lot of things. Not only should it be tiny or reasonably tiny, but it is also going to undergo a lot of electronic and mechanical abuse. A mobile has to be designed to be dropped. You have to design for it. In fact, I think that was the first few ads of Motorola way back 10-15 years ago, that who will go bang, bang, bang with their own phone. And you can see in the background, the person's kid hammering the phone on the playground. So your mobile has to be designed to take some kind of abuse. One. Now here is where you're running into a contradiction. That if you are designing for abuse, you have to make it a stronger, a thicker case, but then you're going to increase the weight. So the way you design a portable instrument like a mobile and a portable instrument like an industrial data logger or automotive data logger are two different things. You have to find a tie-off, and this is where that domain gap plays hell with you. That sometimes that expert, the customer will say, you don't realize this is obvious, of course it has to be so much. Or battery life. You can give as much battery life as you want. Put a bigger battery. Is that sensible? No. So there's always a battle. And that is why probably if you look at the mobile data sheets, you'll see that somebody is promising a talk time of 3.2 hours. Why 3.2? Oh, okay, after final testing, we realize the best we can give is 3.2. Now, the figure we can get away with is 3.2, probably it is 3. But 3.2 is the most reasonable figure that we can throw at the general public. So you say 3.2 hours. So you realize that when you create a product, these are the stages it goes through. There's a battle between all the bells and whistles, the really essential part, and it goes back and forth. And like I said, costs go up, raw material prices do not match the client's expectation because probably you're looking at either a very costly solution or the other word for it is bleeding edge. So bleeding edge a lot of times means bleeding edge. So you go with the latest chip or latest hardware, you're tempted, you search on the web and you find that yeah, it is there, but it's still under development. In fact, one of my customers said that to me. I will not mention the chip company, but he said to me that the engineer has to interact with me. I'm not too sure whether I work for this company or I work for the chip manufacturer. Because a lot of times they promise the latest chip and it's got a lot of bugs. And I'm a lot of times debugging the chip and not the application. So I said, yeah, I've had the same experience with the company. That chip company, I started a product, or rather, I was lucky, I didn't even start the product. I selected a chip, submitted the design documents to the client, and I would say in a way I was lucky. By the time the client gave approval, they stopped making that chip. Unfortunately, somebody else finished such a design on a similar chip, and after 9 months, and that chip he had chosen with the help of the company. In my case, at least I had chosen it off the web. And 9 months or 10 months later, he finishes the product, and the chip company says, yeah, great, wonderful, but we have stopped manufacturing that chip. So that guy actually closed shop and went back to the US. So this is what happens. You're tempted to look at the latest, or what is called a leading edge, and sometimes it doesn't work out. Sometimes the company, the customer will say to you, fine, we're prepared to take that risk. But you have to go back with this kind of honest answer that, see, this is really possible, this is really probable, not very sure. This is what you have to go back, and that is that gap you have to cover. Okay, and then comes the actual coding, testing phase, and you realize that, oops, some things were not clear. Typically, that gap is there in architecture, design, implementation. That what happens is that sometimes the design is not as well done as it should be. So you realize that, and typically this happens in a service industry more than a product company. In a product company, it is not so bad. In a service industry, typically, which is the major employer in your case, typically what happens is that the project is late the day it started because they're trying to fit it in a certain budget. And because you're working in another company, you cannot say that at the end of the day, yeah, okay, we need 2 more weeks. Customer says, fine. Not fine, of course, they will be upset, but they may not pay you for it. They'll give you those 2 weeks, but they may not pay you for it. So you're always short of time. So sometimes architecture and design, there's certain amount of skipping or an attempt to do activities in parallel. So you'll be told, hey, get started with the device drivers. Get started. So, like in the army they say, when I tell you to jump, jump. On the way up, ask how high. Like you know enough physics to realize that's impossible. But that is what happens, that you are told to get started. Hey, start the device drivers. And at the end of the day, or in the middle of the project, you realize that they don't match. You've written a set of drivers, but they do not match the middle layer, or they do not match the application layer. The calls are wrong, or the testing is not done enough. There is a mismatch. And then you add one more layer trying to hammer it all together. So this is another place that you have problems with. So you realize that this is where, and since like I said earlier, you're in the implementation and the testing phase, you're the ones sitting late at night. You're the ones working on Saturdays and Sundays. Of course, a good boss will at least come there and make sure that the canteen is running for you. And a better boss is one who will also take you for a treat once in a while. And, oh, you worked on Saturdays. Wonderful, let's go out to Pizza Hut or whatever is your favorite joint. So this is what happens. You're at those two stages and you're the ones doing the real, or so you think you're doing the real hard work. But there's a lesson to be learned from that. That if you really want to move to the next stages, you have to plan for that now. So agreed, you're not allowed to do the architecture or the design initially. That is, officially you're not allowed to do. There's nobody stopping you from doing it on your own. So no matter how much the boss stands behind you and says, hey, why don't you start at coding? So no rush. Think it over, work it out on paper. You realize on your own, how should this be done? For example, you're writing a driver for SPI. So give it a thought that if you are writing the middleware or the top layer, application layer, how do you expect the driver to be written? So even if the details are not clear to you, you can guess a lot of things. And you can do a great job. At the time you spend in this may be 20% more. But the benefit you will get is that when you move to the next level, from just being the coder or the tester, is when you are in a module lead or a team lead. You're going to have 3 people under you. Rewind back. Now they are just like you were a few years ago. So the same fear factors. I don't think I know enough C, or oh my God, this board involves something like an ADC and I hit analog. So these fear factors are what scare you. And if you're scared of them now, the person coming after you is also going to be scared of them. So when you're a module lead, this is what is going to kill you. If you're not confident, you're not able to guide, you're still afraid of C or whatever, how can you guide 3 people? So for sure, by then, you're probably married or whatever, and your family life is now here. You're never at home. So please start thinking at the lower stages when you're actually a coder, that how the hell can you make this better? That is a very important thing. Otherwise, you wonder, yeah, once I'm a module lead, my workload will be less. I'll be out of this coding and testing phase. No, you won't. You really never get out of the coding and testing phase per se, because there'll always be a junior who's going to mess up the schedule. And that's when you'll have to step up to the challenge. That, oh my God. So somebody said, hey, my routine is done working. Means what? It compiles. That's all. And compiles with 20 warnings. Would you really dare to use such a thing? No, you won't. So this is what happens, that at this stage is when you begin worrying about your next promotion. You always think the boss has it easy. Yeah, he just sits in a cabin, makes an Excel sheet, a few mails, that's it. Yeah, some bosses do only that. True, you're not wrong, but that's at all stages. At all stages. Some people will take it very easy and work only on Saturdays and Sundays. You'll find all sorts of people in the industry, so it's up to you what kind of person you want to be. So becoming a boss is not really easier unless you're prepared for it. Or as there's a famous saying in the army that sweats the most in peacetime bleeds the least in war. So you realize this, that it also applies to us. Okay, moving on. So this is what it is realistically in any embedded development. That at every point you design and plan for a feedback. That you say, if this is what you want, how are you going to test? Whatever you want, what is the sign off? Because that is when will the stage be reached that you get a check. You can't say it's working, not good enough. It is the customer who must agree that yes, it is working. So those are basically the benchmarks at each stage for getting your money. Look at it that way. That unless you put down hard and fast test plan, that this is what is the sign off. So can you just say the display should be bright enough? No. You should have a value that so many lumens is the brightness. Whatever you say, it must have some kind of measurable parameter. Even keyboard operation, bounce, debounce time, all these things have to be quantified, otherwise you're going to be in the forever loop. No, I'm sorry, I don't think what you've done is good enough. You can always say that. And the project never really succeeds. So, besides making your life easy, here are things that you get really the stage to pay off. So you get paid only when the customer says this is done. So remember that you may think, yeah, oh my God, who wants to create test cases? I want to start coding. This is where I can use linked lists. Why am I being not allowed to do that? Doesn't matter, please wait. First think, how will you test at each stage? And then you realize that whether you use linked list or any other technique, any other trick, really doesn't matter. It is the client who has to decide. For example, this is what you will be. I just covered that. Let me cover the concept of workmanship here. Now, unless you're Lady Gaga or somebody, you prefer to buy clothes with both sleeves of the same size. And not too many colors. So what are we talking about as workmanship here? Nobody buys something that is 70% complete. How much is distinction in engineering? 66. Would you buy anything that is 66% complete? Would you buy a shirt where the shopkeeper tells you, yeah, the shirt is fine, only this one sleeve we have not stitched. You can buy it at a discount, take it home and stitch it. Yeah, might do it once in a while for the fun of it. But would you do that in real life? So in real life, 70% is faith. Even 90% is faith. You don't want a vehicle that you have to tilt to start. You'll do that out of sheer compulsion because that was the only vehicles at one time. But today, you pick and choose. Of course, you go for the show. That fancy fairing, that nice display, and all those things tempt you. But as a student, that famous ad, what mileage does it give? We are obsessed with mileage, and that is the core thing you look at. So what do you make? Shoes, mobiles, shirts, cars, aeroplanes. You have to achieve a certain very high level of completion benchmark. And that is what I mean by workmanship. For example, let me give a very popular example. My favorite example about this is a simple line of C code. Z is equal to X plus 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 Y. 5 pluses, then Y, semicolon. Can somebody please explain to me what this means? I can't, and I don't care. Polite company prevents me from using stronger language. I would say I don't give a damn what that line of code means, because it's a horrible way of writing C code. What purpose does it serve? Except to show that I'm too lazy to type properly or tidy. What do I want to do? If I want to increment a variable, why? You don't write code for the sake of code. You write it for a specific purpose. So let's say you want to increment an index. So you increment it and you write there in comments. So if you have variables with the names like X, Y, and Z, your manager should be sent home. You should have meaningful names. You have delivered, as a company, you have delivered all the code, you have delivered the product, it's there under testing, and your company cannot keep you idle. So the team is broken up, people get reassigned to other projects. And 3 months later, the client comes back and says, I think we found these 3 bugs. We have paid, please solve them. Now at this stage, what happens? You're already in another project, and like I said, that project is also late from day one. So you're overloaded there. And typically this request from the customer goes to your senior person. It doesn't go to you directly. Normally it won't. It will go to somebody senior. It will probably, let's say it's a customer in the US. It will go to the person who took the order in the US. And that person also is not really interested in finding the mistakes in your design, whether it is hardware or software. That person is paid to get more orders, either from that customer or the next one. So your mistake is a major headache to that person, though that person is working for your company. So it is going to be a panicked and an irritated mail that the customer is saying nothing is working. And so the things flame up, they heat up, and your senior person here is going to suddenly wonder what the hell is going on, and you will be pulled out of your current project or asked to come on Saturdays and Sundays if you're not already coming, and to figure this mess out. So you stay late nights or work on Saturdays and Sundays and clear up this mess. Now here is that important thing, that if you have not done a tidy job, then do you think 3 months later you can figure out what that chunk of code means? I'm sure you can't. A lot of people in fact say, who wants to sit and debug this code? I'll rewrite it. And this is what typically happens. That you say, oh my God, I can't figure out, yeah, it was 3 months ago. I can't remember what it was, and I'm going to rewrite. Or you and the team lead, your previous team lead in the previous project, you're going to sit together, and that person also is working in some project, some other project, and it's going to be in a very nasty mood. So then the abusing starts. Is this how you write code? Don't you know this much? Don't you know we have coding guidelines? Some companies don't have coding guidelines, so they're only for the show to please the client. It's up to you to follow them. But this is where the blame game starts. And again, like I said, you are at the bottom of the chain, so you take the hit. So this is where it matters that don't worry about writing the shortest line of code. In fact, that strongly connects with urban legends. I don't know, some people are teaching that if you write in C all the code in one line, I'm sorry, that means you try to cram in as much as possible in one line of code, the generated code is smaller. Nobody's shown me an example. And in fact, in KPIT, when I used to go, this was one of the first examples I used to take. That let's try it on any of the good compilers, that let's write x plus 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 y in 3 steps and 1 step, that is y plus plus, then increment x later. And let's see the output code. If you have optimization of, code size is same. It's not really smaller, but definitely once you've broken it up, it's easier to understand. So this is what workmanship means, that don't worry about how you've written the code, worry more how will it work. And for that, realize that no matter how good you are in coding, you will make some mistakes. Trivial, major, hopefully with experience the major ones will go away, the trivial ones will remain. If your commenting is good, at least worst case, you can find the bug. Ideally, even once you're out of the project, somebody else working in that project who has taken over that maintenance should be able to find that bug or confirm that this bug is not there. This is a typical battle in embedded that, oh, the firmware people say the fault is in software, sorry, in hardware, and vice versa. They're a very common battle. I had this very bad experience in a company I was working, and one of my senior most fellows, no, not one of, the senior most guys under me, was testing a serial hardware. And he said that when I connect one serial port, that is run one serial routine, everything is fine. When I connect the second pair of RX and TX, after a few minutes, things go crazy. And this had gone on for a day and a half. He was trying to find the bug. And basically both the routines were identical. All he had done was just rename the variables. So naturally some mistake while copying, some variable name has remained same, global variable, etc., etc. All the analysis was done. I was taking a lot of hammering for this, that how the hell can this happen? So I happened to sit next to him. Finally I said, let me see that demo. I don't take your word for it. Let me see a demo. So he gave me a demo a couple of times. Let's see, I connect the second serial port and now it hangs. So this went on for a couple of hours. For the serial port we ran for 1 hour. It worked. Second serial port, after 10 minutes it hanged. So I said, what is your guess on what could be the problem? He thought he'd take the shortcut, the escape route. He said, well, you know, this board supplied by the client, this hardware, I think that is faulty. I said, fine. Luckily, my own boss was paranoid about these things. So his philosophy was, if you're making anything, make two of. He put it in very vulgar terms, I'll not repeat them here, but that was his philosophy. Never make one hardware. Always make 2, 3, because things do go wrong. In fact, during the first team meeting, he said we had got a very costly emulator from the customer to test these boards. And he said that, who has burnt an emulator before? Naturally, I was the only one who had done it. He said, then it's your responsibility to switch it on in our company for the first time, because this is a 2 lakh rupee item. And you'll realize in a service industry, what is client supplied, even if it is 10 rupees, is very costly. Because to ask the client for one more piece after your damage is a major issue. I mean, that doesn't mean you burn the computers in the company, but it's a perspective. So here again he says that, well, I think this board is faulty. I said, we have 5 of those. Please change as many as you want. And consistently 3 boards he replaced. I made the mistake of walking away for a little while. 3 boards he replaced, he said, yeah, it's happening with all the boards. I said, that's an automotive company with very experienced hardware people. Are you sure you want to blame their hardware? Yes. I said, fine. Now you replace a board in front of me, the 4th one, I'll sit here. So while disconnecting the 3rd board, he disconnected only 4 wires. RX, TX, RX, TX. I said, man, out of experience you tend to have a mental count of all these things. I said, where is the ground connection? What ground connection? Why do you need ground? And this is a guy with 4 years experience, worked in a couple of multinationals. Now, if it was my own company, probably I would have hit him. Working in a big reputed company, you have to be more of a gentleman. So, after half a minute of silence, I didn't know what to say. I said, don't you think ground is needed? No, one serial port's working. So what used to happen was that the hardware we had designed, the test jig, was connected to the PC through a debugger. The customer's hardware was also connected to the PC through that other costly emulator. So the ground loop was getting complete through the earth of the PC. And that is why when you connect two serial ports, that marginal error goes up. Now, this is not really something high-tech. Any circuit you learn, there has to be a return path for the current. What is high-tech engineering in this? Plain common sense. But this is what was going on. And finally, when he connected the ground, the software worked. But I took hell of a heat for this. I think except for the security and the admin and the canteen guy, everybody fired me. How the hell didn't you realize this? I said he's the most experienced guy in my team, and that was my first few jobs. In fact, my first job after many, many years. So I said, he's the guy with the most experience in my team. Am I really to worry about, does he understand the concept of ground? So that was a good education for me. And then I realized, of course, he had taken a lot of shortcuts, even renaming of variables he was lazy about, a lot of things. So the concept of workmanship here means not some fancy code, not some fancy vague part of C, not some obscure IC that seems to do everything. In fact, when we were in college, every time we used to read about a new chip, we used to go to our professor and say, so there's a new microcontroller. That time microcontroller is a relatively new concept. New microcontroller. In fact, he sits in this building now. New microcontroller. Yeah, it does this, it does that. And he would coolly look at us after a few minutes and say, oh, you're referring to the 8692. And we used to wonder, no sir, no, I'm referring to the 80186. Yeah, that's right. So he used to try to bring us back down to earth, that every day there will be a new chip. Of course, there's a pre-internet days. So there will be a new chip every day, something newer, fancier. It really doesn't matter so much as how much you do the thinking and you do it well. So this is what really workmanship means, that you aim for that 100%, with first realizing what that 100% is, not fancy C code. For example, you realize that in an embedded project, you probably, unless you have a good OS down below, you should never be using linked list or malloc. I'm not going to the details now. You're tempted, hey, I'll save memory by using linked list. No, you're not. Don't worry about the memory. Down the line, you'll realize that your chip manufacturer, the chip you have chosen, really is not worried about the cost so much as getting the order. So a memory, a chip with 4K and 8K memory really costs the same to the chip manufacturer, minor difference. They do that price tricks. That is, they are selling the 4K chip at the price they want to, and the 8K chip is the bonus for them. But when you talk of automotive company, they buy by millions. So if the automotive company says, hey, I also want the 8K chip at nearly the same price, you won't get this treatment, but the automotive company, your customers, will get that preferential treatment. The guy will stand up and say, salute, yes sir, I will give it to you. And that's the way that you go back and say, sorry, this code does not fit in 4K or in 400 bytes of RAM. It requires 600 to work reliably. And maybe for the initial rollout, the customer will say, yes, go ahead. Because finally the product has to be reliable. You cannot behave like Microsoft and say, yeah, unhandled exception error. So your brake is not working. That's why you're working. Brake is not working. Yeah. Oh, there's a small bug. But no. Cars have with reset button. So you'll have a common reset big red button which will reset all the electronics. So this is a bit like parachute with warranty. If it doesn't open, please come back, I'll replace it free. So you can't have that kind of business because your customer is a 6-foot hole in the ground. So this is what embedded workmanship is, really making it work. Minimum specs, first make it reliably work. Then comes the bell and whistles. And all in all, the customer doesn't care, doesn't know, doesn't see your code. They only see the working. Does it do the job? That's all. And for that, they have very rigorous testing. When I delivered the hybrid control to an automotive company in Japan, the test jig, I had a moment's panic when they told me, we reached on Monday, I think. Yeah, on Wednesday they told me that, oh, we are happy with your test jig. Now this jig was required because in a hybrid battery control, the voltage is around 300 and the current is around 60 amperes. So you cannot have such high voltages during software testing. So what do? We made a test jig for it that used to simulate all the signals from the battery pack, the communication, talking to the main processor, the CAN and everything. So we went to deliver this jig. And they said on Wednesday or Tuesday evening, I don't recollect exactly, oh, Thursday we are having a meeting, there will be 25 people coming. I had a moment's panic. Firstly, I don't know Japanese. So I had a moment's panic. 25 people I'm going to face from the customer who may ask all sorts of questions. Luckily, this is a big company I was working for, TCS, so I raised a red flag. I said, I want an interpreter here no matter what. Thursday morning, I want an interpreter here. I don't care if I have to pay the taxi fare, get one from my office in Tokyo. And sure enough, there was an interpreter. Luckily, they didn't have questions for us. But that is what the level of testing they do. So 25 people, that's the team I had in India. So there are 25 people cross-checking our work there. And they were not interested in the code. They didn't ask me a single question about the processor, what I use in the test jig, whatever. We don't know, we don't care. Does it do all this simulation? Because there's a huge battery pack. Does it simulate the battery pack? Because each battery pack, it had its own controller. So all this, does it do? Does it do it this way? That's all they were interested in. So that also boils down to the processes and documentation that really you'll run into a lot of things called processes. And tied to that is the documentation. So initially you're tempted, hey, boss wants a report, I'll give a report. Just fill in the blanks and be done with it. Yeah, probably time being short, you'll do that. Third part of the story is embedded tools, which is also tied effectively to the workmanship is, please look at your tools. There's some damn good tools that will make your life easy. For example, you get good simulators. Now, do simulators equal the real stuff in the world? No, they don't. But you as a learner, as a beginner, will benefit a lot because you can see your code in action. So when you see your code running, you see the variables change. A lot of times you catch a bug before it happens. You realize, hey, oops, that index seems to go one past. It's very common to get the for loop wrong. Very common. So a simulator helps you to realize a lot of your own bugs, catch them a lot of times beforehand. In fact, Kyle, as in KPIT, we did a complete can-to-can communication purely on the PC, got that code working, and on the hardware, those kids, just like you, just a year senior to you, they got it working within 2 days. The complete, it had a RTC, it had CAN, it had serial communication, ADC, everything together. And that is what I want to highlight about your project. At that point, I would like to, please don't take this personally. That is what your project should be also. Those 29, oh sorry, was it 39? 39 subjects. That is what your project is about. Try to choose a project sufficiently simple, but that brings together all these subjects that you have learned. Don't try to choose a project that is something very challenging in one aspect. That is typically you got 20 ICs, so by the time you finish the artwork, it is end Jan. And you're sacrificing everything else, your extracurricular activities, your extra study period, everything else, you're sacrificing just to get that hardware working. And by the time you actually get the hardware to run somewhat, it is March end. And that last preparatory leave is what is wasted in trying to get the software working. So please don't do that. A project is supposed to be the bringing together of all those 4 years of your engineering. In fact, typically that's why I've stopped sponsoring projects nowadays, my suggestion used to be, and I've been sponsoring projects since 85 or 86, I don't recollect, that if the professor says this is too simple to be a BE project, then I know I've chosen the right topic. Because I expect completion. Making you cry with a complicated project, why do you need a project? Two hoodlums on a dark, lonely road are enough to make you cry. Why do you need to do engineering? Point of a project is that the pleasure of completion. You can cut onions for 10 years, you still don't know how to make pav bhaji. It is when you start putting it together, you realize the pleasure and the benefits. Then you realize that you are under the worst impression that all you have studied is theory, you have no practical knowledge. Actually, you have not even studied theory in the correct sense. You know the theory, but because you have not used it, you are not confident about it. So that is what answers that question. 75% of the engineers are useless. That is wrong. It is part of the industry's fault also that we don't bring this point up. So project should be sufficiently simple that you put together all these things and you get the pleasure of completion. It's like the difference between a sandwich and a paratha. Sandwich is easier to make, and you'd rather have a sandwich than a badly made paratha that breaks. Only your parents will appreciate. Yeah, this is how we eat paratha, in bits and pieces. No, really paratha has to be complete, nice and tasty. So this is what it comes to. Your project should be really focused on improving your understanding, improving your confidence level. Coming to last few things, that among the urban legends that I tackled was Z is equal to X plus plus plus. So there are a lot of such urban legends in all fields, engineering, medical, you look at it, all fields have that. Please don't get taken by these, cross-check. Just because I say so doesn't mean it is true. Ask for references. Well, you say this, fine. Proof. What is the proof? And that also brings you down to this most important thing is, you're wondering that what should you focus on is the title. And there are 6 points. How can you focus on so many things? My point is they're all tied together. And you have to differentiate, okay, job interviews you typically are asked first at the jargon. Okay, have you heard of USB, SPI, I2C, this, that, all peripheral buses, then CAN, this, that, I understand. So you're going for a job interview, you would like to know all the jargon that you can throw at. If you can't answer the question, at least confuse the guy across the table. Good, understood, accepted. But at some point, you'll also have to worry about your understanding. So like I said, as you go up the chain, if your understanding is weak, you're going to spend too many days and nights in the office. So please look at that also. I think that covers quite a bit. Thank you, folks.